So this is my project. It's a water tag gun. This is pretty much a purely mechanical project in comparison to everything else that's going on this summer. I have thought about putting in my controller to mix things up a bit, but not for a short-term goal. So why I wanted to do this, how many people like paintball, laser tag, and other things that are like, or Nerf, games like that where you're actually running around and trying to hit people for fun, I guess. Yeah, it's pretty popular. So part of my goal with this was that like you could sort of customize and build your own device where you're going to be shooting pellets of water instead of like a paintball cartridge, or paying like probably sometimes high facility fees to do laser tag or elsewhere and having problems with finding space. So my thought with this and having it be a game was you add dye to the water. Everyone wears white shirts or something else light colored, and you get a cool tie-dye shirt at the end. So it'd be fun. Also, one of my aims to do this is so it's safe, so the pressure of impact doesn't hurt, or it's just like, it's a light splash. It's like whatever, because I've heard some of my friends complain that from paintball they end up with some bruises, and it's not always fun. So in terms of structures and materials, for propulsion, I would prefer to use a CO2 cartridge like they use in SodaStream or in airsoft rifles. Problem with those are very high powered, so I would like to develop some sort of diffusion, pressure diffusion. If you guys aren't aware, my background, I'm an aerospace engineering major, so working with fluid dynamics, knowing the math and physics behind it, that is my background in this. For a water supply, I was planning on using one of those flexible water bottles so you can see how much is left based on how much it deflates. Everything would lie flat. But one of the problems with something high speed, high velocity, that could end up being high speed, high velocity is that the result would not be drops of water, it would aerate and become mist, or worse, become just a complete stream. Nothing would separate, and that's not really the point of the game. One of the other issues that I've been thinking about is the actual structure of the device, whether or not I would like a skeleton design where it's like you have basically strips of plastic encompassing certain parts and to just provide basic support, or to have an all-encompassing skin and structure. So part of the math and physics of this is making sure pressure applied will not cause like surface tension to deplete, drag forces to make things funky, make sure it's safe, and that the pressure launch from using a CO2 cartridge would not cause the structure to break apart on the first try. Because I plan on this to be 3D printed, most of these would have to be in pieces put together. So having a stable structure that can resist the impacts and the stresses of this would be a great thing, because it's much more cost efficient. So technology, 3D printing, CO2 propellant. I mentioned I've been looking at SodaStream. Unfortunately, that one may be too large, because if I do go with a skeleton design, the only thing that would probably be printed is the trigger mechanism and the small barrel. So theoretically, it would be like a small thing here, trigger, barrel, and then attached here, you have your cartridge and then the water bottle on top, theoretically. Still working that out. So plans, I would like to complete the CAD model by the end of the summer with a design that minimizes the stress. I have worked a lot on structures in the past year using programs like Abacus to analyze frequencies of whatever it's doing to well, make sure it doesn't fall apart. And my second goal is to figure out the equations. So if you find that whatever CO2 pellet tank that you have, if you find that it's more variable, you get what you can get your hands on, and you're able to figure out, like, okay, is this really safe to use? So if you're looking for something for little kids, for example, knowing which kind and what to expect, rather than like you have a bunch of college students who don't really care, who can afford to be a little less cautious, depending on health reasons, and they're able to do what they want. Part of why I wanted to do this is that fluid mechanics is really great to learn and play around with projects, and being able to figure out, it's like, okay, I'm going to be using this for a game, I can design and play around with this. These are the equations that I'm working with, this is what affects it, and this is what I'm going to see come out of it. Thanks to Professor Goldfit, Dorothy, Sean Sullivan on the RCOS. Are there any questions?
So will there be a water gun fight after at the end of this, in your next presentation? Will there be a water gun fight?
You know what, maybe next semester, maybe in the fall. What I didn't realize with the RCOS pay period, I was not able to get materials in time, because a lot of this is I'm going to have to buy a lot of things and figure out what works, or pay to have things done, and to have that ready in 2 weeks is not entirely reasonable.
Yeah, after the beginning on the fall semester.
Yeah. So, would people like to see this, or any suggestions?
Certainly, we'll have a water gun fight.
Yeah.
When you need stuff 3D printed,
Okay.
have access to a bunch of 3D printers.
Awesome. I'll definitely let you know. It's just like trying to figure out, like, okay, so the pressure needs to be diffused. It's figuring it out for it. Okay. Thank you.
Thanks, guys and girls. You did a fantastic job. The projects are all smiles, beams. So continue the job, continue your good work. And more importantly, post your slides to the group. We enjoy reading about it. I usually blog. My writing the blog becomes easier if I can read your slides again. So please post the slides. And there are lots of interesting projects. Dave Goldschmidt is under a lot of pressure to get this RPA website coming, so CS website is a great high priority. So help Dave Goldschmidt out.